let me elaborate a bit about omega f cross VB slash f. I'm quite sure some of you are still quite blurry of this concept. So how do we evaluate a shortcut for omega f cross VB slash f? So assuming now I have VB slash f is equals to A direction theta, and omega f is equals to a number B, and B is negative is counterclockwise, and positive is B is negative clockwise, and positive is counterclockwise. So in this case, to evaluate this term, it's just equals to B times A times B, direction theta plus 90 degrees. That's what I'm trying to say. So the shortcut for this one, assuming that velocity of B slash f is equals to A direction theta, and omega f is just number B. And B is negative if clockwise and positive if counterclockwise. Then what I do is I just take the A, put it here, take the B, put it here. Direction theta is this theta here, plus 90. That's a shortcut for this equation. Now, A can be negative, don't bother, just put negative here. B can be positive or negative, depends on it's clockwise or counterclockwise, just put it here. That's all. Right? So that's what I'm trying to emphasize actually in the previous question. I should have put it this way, much easier to explain. Okay, now, let's go to the final question in the tutorial, and it seems very intimidating because we're no longer dealing with linear equations, right? We're no longer dealing with relative motion, which is linear. Instead, our relative motion now is a circular motion. So what I'm trying to say is this, okay, now, the question says the platform is rotating about a fixed point O. So this whole platform is rotating about a fixed point O. And with a constant angular velocity of 0.3 radian per second, counterclockwise in this direction, like this. Now, the constant speed, particle P, this particle P, which is our point of concern apparently, is rotating in a velocity of 10 millimeter per second, circular motion with respect to platform F. In other words, if you were to view from the perspective from the platform F, point P is going in a circular motion which is clockwise about a point O double prime. That is what you view from the perspective of F. So, the question asks about the absolute velocity of P and the absolute acceleration of particle P. Let's talk about velocity first. Velocity of P apparently is equal to velocity of P slash F plus velocity of P prime. Now, what is velocity of P slash F is given in the question. So this is P slash F, sorry. Yeah. The question says that the velocity of P in the body's perspective is a constant velocity of 10 millimeter per second clockwise about O prime. So Vp slash M is just 10. Now where's the direction? Now please take note, it's clockwise. So it's position angle minus 90 degrees. Position angle of P with respect to O double prime is 30 degrees. Minus 90 is just negative 60. Now why can I say so? Please take note, Vp slash F is a velocity of P in F perspective, which in this case is a circular motion. A circular motion with a clockwise direction. With a clockwise direction, the velocity component has an angle of position angle minus 90, which in this case is negative 60, because 30 minus 90 is negative 60. That is Vp slash F. We solve for Vp slash F. Now, what is Vp prime? Now, P prime is a point which belongs to the body F but occupies the same space as P. Now, the body here apparently is body F, is this whole board. This whole board is one body, right? You know, there's only one body, so it's clear to see so. Now, for this body F here, how do we denote P prime? P prime belongs to exactly at this location here, right? This P prime. But this P prime, please do not get mistaken, this P prime is not the point P itself. This P prime belongs to the board, but at that very moment, occupy the same position as P. So since P prime belongs to the board, and the board is rotating about O, P prime must be rotating about O. So in this case, we can definitely say that P prime is a circular motion about O. Let me repeat. P prime is a circular motion about O. Velocity of P with respect to F is a circular motion about O double prime. It's different. In F perspective, P is going to this circular motion, but the velocity of P prime, which belongs to the body, is going circular motion about O. So in this case, if O is going in if the body itself is going in the counterclockwise direction of 0.3 radian per second, it is very clear to see that, I just need to draw a line from O to P prime. This is my so-called RO P prime. And the velocity of P prime is, of course, in this direction. That's the velocity of P prime. Now, how do I know the velocity of P prime in this direction? Because first of all, I know P prime is going circular motion about O. And in this case, I basically have, I basically have this, what is it called, position direction here. And this will be 90 degrees too. So, how do I find P prime? Now, first of all, through geometric analysis, which I'm going to leave completely up to you, I'm not going to dissect it, you can actually find this angle. This theta P prime. You can find this angle. This angle can be found through your geometrical analysis. You can just find using geometrical methods based on the equation, based on 20 and 40, and do some manipulation using tangent and stuff like that. You can find this angle theta P prime here. So Vp prime is just equals to omega f, which in this case is a positive 0.3 because it's counterclockwise, times ROP prime, which is this length from O to P prime here, which can also be found using trigonometry. Direction theta P prime, which is the position angle of P prime with respect to the center O, plus 90 degrees. Why is it plus 90? Because P prime is going in counterclockwise direction. So the velocity is definitely plus 90. That's all. So in other words, through geometrical analysis, we can find ROP prime, we can find theta P prime, omega f is given in the question, we solve for Vp. Simple as that. We solve for Vp. By just adding these two things together, and you must sub the values inside, definitely. Okay? Now, how about for velocity acceleration of P? How do you find acceleration of P? Acceleration of P is a bit different because we know that it's a bit longer. It's equal to acceleration of P with respect to F plus acceleration of P prime plus omega F cross Vp slash F. Acceleration of P with respect to F. What is the acceleration of point P in F perspective? Now, please take note, in F perspective, point P is going in a constant velocity circular motion. If it's a circular motion, it means there must be centripetal acceleration. So since it's a constant velocity, it means that there is no tangential component. There's only centripetal component. So acceleration of P with respect to F, the centripetal acceleration, pointing towards the center of rotation, which is O double prime. So in this case, acceleration of P with respect to F is just equals to Vp squared, Vp F squared, is equals to V squared over R, right? And the V squared is just equals to 10. 10 squared over R. R is just equals to PO over prime. This 10 squared is basically the velocity of P with respect to F. Let me repeat. What is the acceleration of P with respect to F? First of all, you first dissect what is velocity of P with respect to F. Velocity of P with respect to F is a circular motion of a constant velocity, a constant speed, right? It's a circular motion of a constant speed, which is clockwise about a center O double prime. So acceleration of P with respect to F apparently is equals to the centripetal acceleration. There's no tangential acceleration because there's no constant velocity, constant speed. So it's equals to V squared over R. It's an alternating solution to omega squared R as we know. And the direction is pointing directly towards O prime, which is 30 plus 180 or minus 180. Do as you please. I like to plus, so it's 200. Okay? This is the centripetal acceleration of P with respect to F. Originate at the origin of O double prime. Now, there's no tangential component because alpha is 0. Now, for acceleration of P prime is acceleration of this point here, P prime, that belongs to the body F. Now, P prime, as we know, is rotating about O instead of O double prime. But since the body is also going in a constant velocity, omega, about O, we can conclude that acceleration of P prime only have a centripetal acceleration about O. There is also no tangential acceleration because omega of the body, here omega F is omega F, is actually a constant, as given in the question. So, in this case, acceleration of P prime is also a centripetal acceleration, which is just equals to what is Vp prime. Okay, so it just equals to Vp prime, magnitude of Vp prime squared. Oh, sorry, we have omega f, sorry. Yeah, you can just use omega f squared, times r, which is actually r OK prime. And the direction is definitely pointing towards O. So what is the direction of pointing towards O? Now, theta p prime is pointing downwards here, so we just theta p prime minus 180. Okay? So, let me repeat, theta p prime is pointing towards p prime. So, if you want to point towards O, it's opposite of theta p prime, so it's theta p prime minus 180. You get the answer. Okay? Now, for this component here, just do as I said. Omega f, in this case, it's counterclockwise, so it's positive. Now, what is Vp slash f? Now, Vp slash f is 10, right? The magnitude part, so just put a 10 here. Direction is equals to the angle of Vp slash f, negative 60, plus 90 degrees. That is distance, using the shortcut that I just said before. So let me repeat, omega f cos Vp slash f is a shortcut. The shortcut is basically put the angle. First of all, write the angle of Vp slash f, which is negative 60. Then you add 90 degrees to it. In the front part, you put the magnitude of Vp slash f, which is 10. If it's negative 10, just put negative 10. And this part here, put the omega f. If it's clockwise, put a negative. If it's counterclockwise, put a positive. In this case, it's counterclockwise, so you should put 0.3. So in other words, this whole thing, since omega f is 0.3, should amount to 3 direction. Yeah. And for this part, as we can see, this term is known. You can find geometrically RPO double prime. This part is known. It's given in the question, 0.3. This part is known. You can find geometrically. This theta is also known. You can find geometrically. Just add them together using calculator or put it into I and J, and you get acceleration of P. That's all. So we are done with this question here. So I didn't give you the answer, but just try to work it out and see if you can get the y is equal model solution.